In this video, we will learn the shape and space 4. And this is one of the most important chapter in your textbook. You can see the page number 271. And in this chapter, we are using the trigonometric ratios like sine, cos and tan. And I hope that you have gone through these things in the previous chapter. So let's have a brief introduction about that. I hope everybody has the idea of right angle triangle. It's a triangle in which one angle is 90 degree. That's this angle. Sometimes it will be like this, sometimes it will be like this, and sometimes it will be like this, sometimes it will be like this. So one angle should be 90 degree. That's called the right angle triangle. And in this right angle triangle, the opposite side to this angle is always called the hypotenuse. And this side is the hypotenuse. This side is the hypotenuse. This side is the hypotenuse. Two things we know about the hypotenuse. First, the hypotenuse will be opposite to the right angle. Second, it is the longest side of the right angle triangle. This thing you should mention, you should understand and learn. Second thing is that we have other two acute angles. That is less than 90 degree and greater than 0 degree in the right angle triangle, like this and this. Okay, now how to name these two sides other than hypotenuse? These two names, these depends upon the angle chosen. For example, if I am choosing this angle, this is theta, I am choosing this angle, I am taking the consideration of this angle and considering this angle. So this side is then adjacent to this angle and this side is opposite to this angle. This is opposite, this is adjacent, this is hypotenuse. Here I am choosing this angle, then this side is adjacent and this side is opposite. And here I am choosing this angle, then this angle is adjacent, this side is adjacent and this side is opposite to this angle. Here I am choosing this angle, so this is adjacent, this is opposite. So we can see in every right angle triangle we have hypotenuse, we have adjacent and we have opposite sides, and adjacent and opposite depends upon the angle chosen. For example, I have chosen this, so this is now adjacent. If I have chosen this, then it would have been adjacent and this would have been opposite. So it depends upon the angle chosen. Now you can see these are the T ratios or trigonometric ratios, sine, cos and tan. And these are simply, I will write O, A, O, H, H, A. That means sine of any angle is the ratio of opposite side and hypotenuse. And similarly, cos of any angle, that's cosine of any angle, is equal to the ratio of the two sides. And the tangent, tan means tangent of any angle, is the ratio of the two sides, that is opposite and adjacent. You can see here, this is hypotenuse, this is adjacent, this is opposite. So what if I want to write sine theta, sine of angle theta, that is opposite by hypotenuse, opposite is AB, it's AB divided by AC. If I want to write cos theta, that is adjacent by hypotenuse, that is BC divided by AC. If I want to write tan theta, then what is that? Tan theta is opposite, that's AB divided by adjacent, that is BC. Now I will put here the x. Now I will write the sine x, that is opposite divided by hypotenuse. Now check here, when I am taking the x, then my opposite is BC. hypotenuse is same, that's AC. Cos x adjacent. When I'm talking about the x, I'm taking the x as angle, then my adjacent is AB and hypotenuse is same. And tan x, what is my opposite for x? That is BC. BC divided by what is my adjacent? That is AB for x. So similarly we can say this is actually the opposite by hypotenuse, this is adjacent by hypotenuse, this is opposite by adjacent. So whenever we are doing the problems related to this from the shape and space 4, we know there is the application of cos, sin, cos, tan, other trigonometric ratios. So always you should write on the left side on any rough page sin, cos, tan, OAO, HHA, so that it will be easy for us to do the sums, to do the problems, to understand and to learn and to speed up to write the solutions. Now directly coming to the exercise 1 star. Exercise 1, sorry. It's find x. It's like this, triangle is like this. The first question, it's the page number 274. 274. The diagram is like this x, this is 4 and this is 38 degree. We need to find x. Now see, this is right angular triangle. The angle is 38 degree. You can see this side is opposite and this side is hypotenuse. And I told you always write OAO, HHA. This is sine, this is cos, this is tan. Now you can see this is hypotenuse, this is opposite. Opposite hypotenuse, so I can write sine 38 degree is equal to, what is opposite? Opposite is x divided by 4, because I know it's opposite by hypotenuse. Now sine 38 degree into 4, I am doing transposition, then I will use the calci, I can find the value of the x. That's it. Now next you have to find the value of x using the calci. The next you can see it's like this, second one. What is that? It is here 65 degree. And right angular triangle is this, right angle is this is x, this is 12. Now you can see this side is opposite, this is adjacent, and this is hypotenuse. We need to find the x, so nothing to do with the opposite. So it is adjacent and hypotenuse. So you can see here it's cos. So I will write cos 65 degree is equal to what? Adjacent by hypotenuse. That's adjacent x by 12. So cos 65 degree into 12 is equal to x. Now use the calci. You can calculate on the calci, x is equal to, you will find. All other questions are easy. Only to think is that we have to identify the sides, which is opposite, which is adjacent, which is hypotenuse, and then we have to check whether to use sine, cos, tan. Then we have to use the calci so that we can calculate the values. It's very easy. Now I will directly come to the point, come to the question number 7. You can see the question number 7. Please read the question number 7. What is it? It is a 3.8 meter ladder makes a 65 degree angle with the ground rests against a vertical wall. Find the distance of the base of the ladder from the wall. So it's a wall like this. A ladder is like this. Like this. This is question number 7. This is the ladder. Okay. So this is vertical wall. It makes an angle of 65 degree at its foot. You can see the ladder is how much? It is 3.8 meter long. And we need to find the distance of the base of the ladder from the wall. So distance of the base is from the ladder. Base of the ladder is this from the wall. We need to find this x. So you can see this is what? This is hypotenuse. And for this angle, this is adjacent. And we know OAO, HHA. this is sine, this is cos, this is tan. You can see this is adjacent, this is hypotenuse. Adjacent hypotenuse. Directly I will use cos 65 degree is equal to x divided by 3.8. So cos 65 degree into 3.8 is equal to x. So I can find here the value of x is this. Therefore I can write finally the distance of the base of the ladder from wall, distance of the base of ladder from wall is whatever you get. The answer here you can use the calci. It's very simple question. This is actually here the wall. Very simple question. Now next, a kite is at the end of a 70-meter string. The other end of the string is attached to a point on a horizontal ground. The string makes an angle of elevation of 75 degree with the ground. At what height above the ground is the kite flying? You can see the question number 8. It's very simple. Like this. This is the length of the kite, the string of the kite. It is 70 meter. And the angle of elevation here, the angle of elevation of the string with the ground is 75 degree. This is the 75 degree angle of elevation. And we need to find the height of the kite. Like this. This is height. This is length of the string. This is, so this side is hypotenuse. This is x. This is opposite. What we will use opposite hypotenuse, that is sine 75 degree is equal to, what is opposite? That's x. What is hypotenuse? That is 70. Doing transposition, it is sine 75 into 70 is equal to x. You will get the answer in meters. That will be the height of the kite. Therefore, you can also write height of kite. Whatever you will get here, the answer you can write in meters. That's it. It is very simple. It's very simple. Now moving to the exercise 1 star. Now you can see the question number 1 from the exercise 1 star. Is a triangle. In the triangle there are two sides are equal. This is isosceles triangle. So this is 7 meter, this is 7 meter. So when we have the two sides are equal, so base angles will be equal. This is 62 degree. This angle will be also the 62 degree. Now the question is asking find BC. We have to find the length of the BC. You can see, since the two sides are equal, the opposite, you can see the sides are equal, then their base angles are equal. If we draw here a altitude or a perpendicular, what about this perpendicular? This perpendicular, like AD, this will bisect the BC. That means BD is equal to DC. That means if this is x, this will be also x. So what we will do, this is also the 7 meter, because these are the opposite sides of, these are the sides of adjacent sides of the isosceles triangle, or we can say simply these sides are equal. So this is 7 meter, this is 7 meter. Now this if we will find the x, we can find the BC, because this is x and this is also x. Now see here, for this triangle, this is hypotenuse and this is adjacent. So what I will do here, you can see adjacent and hypotenuse is cos. So I will take cos 62 degree is equal to x divided by 7. So I will write cos 62 degree into 7 is equal to x. Here we will find the value of the x by using the calci. Once we will find the value of x, then what we will do, we will write BC is equal to twice x, 2 into x, because 2x are there, or simply we can write x plus x. That is, what is the measure of x, you should add there, and you will get here the answer. You got it? You have to do the calculation only. 60 cos 62 degree into 7, you will get here. Then you have to do BC is x plus x. What is the x? You have got here the value. This value you will put here, this value you will put here. You will double this value and you will get the answer finally. Now the next question is find LM in the isosceles triangle. One more question is same question is like that. Question number 2. Here once again you will do like that. It's like this. Question number 2. What is this? Here we have about, it is 62 degree this angle. And here it's L, it's M, it's N. These two sides are equal. Now you can see what to do here. We need to find the LM. What I will do here, we will draw here the perpendicular bisector. This is 6.8 centimeter. So it will bisect it. It will become what? This will become 3.4 centimeter. This will become 3.4 centimeter. Is that clear? This is 62 degree. This will become 31 degree. This will become 31 degree. And this is 3.4. Now we know, you can see for this angle, this is hypotenuse, LM. And this is opposite. Now you can see we can directly use sine 31 degree is equal to hypotenuse, it's x divided by it's opposite, 3.4 divided by what? Divided by x. Now doing transposition, x will be written here in place of this 3.4 divided by sine 31 degree. You will get here the value in centimeters. It's very easy. You can do it. It's very easy question. Now next you can see the question number 3. What is 3? There is a triangle like this. It's AC. Here it is BD. Here it is right angle. Here it is 30 degree. It is given. And here it is 5 meter. You can see the triangle. Here it is 7 meter. So we need to calculate first AD. Where is AD? This AD we need to calculate. For first part, it's very easy to find the AD. This is opposite. This is what? Hypotenuse. So we will use sine 30 degree is equal to opposite. Opposite, it's AD. AD divided by 5. Then you can use sine 30 degree into 5 is equal to AD. Now you found the value of AD. AD is equal to some value using the calci. Now next point is find BD. Now we have to find the BD. How to find the BD? It's very easy. You can see here. I will put here. Now from the same. Now this side is adjacent for this. I can see for B part cos 30 degree is equal to adjacent by hypotenuse, that is BD divided by 5. So what is that? That is cos 30 degree into 5 is equal to BD. That is BD is equal to, you will do it on the calci, you will get the value. Now next, the area ABC. We need to find the area of ABC. The C part is, you can see area of triangle is area, it's 1 by 2 into base into height. That's 1 by 2. What is base? That is AC. What is height? That is BD. You can see 1 by 2 into, what is AC? AC is AD plus DC. AD plus DC into BD. So that's 1 by 2 into what is AD. AD I have found here. You will put here the value of AD. Then DC. You will put the value of DC, that is 7. Then BD. You will put here the value of BD. Then you will calculate, you will get the answer. Now the angle C. Now you need to find the angle C. How to find the angle C? You should understand this. Angle C. I can write here, this is for this triangle. This is which part? It is D part. From D part, from triangle, it's not necessary to write, but for your, so that it will become easy for you to understand, that's why I'm writing. From triangle BDC, you can see here, this side is for this is adjacent, this is opposite for this. Like BDC, if I will draw here, you can see it's B, it's D, it is C. We need to find this angle. So this is opposite, this is adjacent. So I can write here cos C, tan C. Tan C, because opposite by adjacent is equal to, what is adjacent? That is DC. What is opposite? That is BD divided by DC. Now we will put the value of BD and DC. I can write C is equal to tan inverse BD divided by DC. Put the value, you will get the answer. The values you got from here, the value of BD, the value of DC, we know DC is the 7. It is 7. The value of BD you have found here, you can use here and you can find the angle, the measurement of angle C. Now the question number 4 is find the area of an equilateral triangle of perimeter 12 meter. So it's an equilateral triangle. It's, for example, it will be x meter, x meter, x meter. So I can say x plus x plus x is equal to 12. So 3x is equal to 12. That means x is equal to 12 by 3. So x is equal to 4 meter. So one side is what? 4 meter. Area of equilateral triangle. There is a perfect formula. A particular root 3 by 4 into side square. So that is what? Root 3 by 4 into 4 square. What you will get? That is root 3 by 4 into 4 4s are 16. 4 1s are 4 4s are. Then 4 root 3 meter square. Or you can use the calci 4 into root 3. You will get the answer of this. This is the question number 4. Question number 4. Find the area of an equilateral triangle of perimeter. Perimeter is 12. That's why we are adding x plus x plus x. All the sides of an equilateral triangle are equal. X plus x plus x, that's 3x is equal to 12. So one side will be 4. 4. So area of an equilateral triangle, there is a perfect particular formula, root 3 by 4 a square or root 3 by 4 side square. So what we are putting, side is 4, 4 square. Then we are doing the calculation, simplification, we are getting the answer. So this was about exercise 1 star. The remaining questions are very easy. Only you have to use these sine, cos, tan,